Hello guys, welcome to another video from Behawk Gaming. Today we have an Asus RTX 3080 Ti, and it was actually sent into Asus for a warranty repair, and we can already see by the sticker here they've sent it back as a no fix because this is deemed as customer damage. It has a small crack by that locking tab, so we're gonna inspect it a little closer and see if this crack's actually giving us any problems or if it's a memory related problem. From initial inspection we can see some bending on this back plate. I'm not sure what's going on there, but we'll take a look. So first we're going to do a few checks as normal to make sure we're not working on something which is already dead. Right, so with our meter in diode mode, we're going to check the first data pair. Which is good. Okay, we're going to switch it over and we're going to check the ref clock plus and minus. And they're both good. All right. What we're going to do now is just a simple check for shorts. So basically in beep mode, so if I touch my probes together, it beeps. And we're checking 12 volts from the slot. And 3.3 volts from the slot. And no beep, which is good. So we're going to turn it over now, and we're going to check the external connector. Nothing. And nothing. So this card should be safe to plug in. We're not going to do that though, because we can see some screws are loose. So we're going to actually strip it down, and we're going to inspect the PCB before we do anything else. Okay, so we have the card now stripped down. As you can see, we have the sticker here from Asus, who have rejected this warranty claim. This is user damage, and it's commonly caused by the card sagging on the back end. So this has been used without a support bracket. It may have been damaged in shipping. We're not entirely sure, but it's very common for this damage here to be associated with bad memory modules and sometimes rip traces under the core on this end as well. So let's get into some measurements and see if we have any problems there. Okay, so we're set up here now. We're going to go over our normal resistances first in resistance mode. And we're going to start with the external 12 volts. I'm checking with one of these resistors here. And because it's rising, that's good. Checking the other one. That's rising, that's good. Checking from the 12 volt slot. That's also good. Checking, this should be 5 volts. It looks perfectly normal. Checking, this should be 1.8 volts. Happy with that. And this should be PIX, should be low. And ohms, that should be alright. And this should be memory. And that reading is normal. Considering that all our resistances look normal, we will plug the card, boot it, see what we're missing. Okay, so we have our card set up. We're gonna power it on now and see if our crystal gets warm, and then we'll also check it for voltages at the same time. Okay, so this is the first time the card's been powered on now. And booting. Okay, it's getting warm, but it's very marginal. So I think it'll be safe to measure. Let's go over our voltages. So starting with the 12 volts external. That's good. That's good. Checking 5 volts, which is perfect. Checking 1.8 volts, which is good. Checking PEX, also good. Memory, also good. Checking V-core, also good. Right, so our next step now, given that we have all our voltages, is we're going to be looking at the PEX reset gate. It's also common to be running in this area of traces, so it may be that has been severed, and we'll look at repairing that if that's the case. Right, so we have our card flipped over now. Our PEX reset gate is located here. We have confirmed it is still connected to the trace at the bottom, down here. So we just want to check for voltages going in and coming out, as well as the control voltage for the chip. So we're going to power it back on now, and then we'll take those measurements. Okay, and powering on. We have nothing. Does help if you connect the ground probe. So we're going to connect that now, and we'll retake that measurement. Okay, just taking the measurement again. And we have 3.3 volts, which is normal. .8 volts is normal. Pretty sure that was our output. And 1.8 volts, so our PEX reset is normal as well. Right, we've also done a quick physical inspection. The card's not missing any components. Everything looks new and clean. At this point, we have all our voltages present. Our PEX reset is working as it should. So at this point in time, we are considering just touching this crack with a grinder, just to see the traces running through there, and see if we have any damaged traces. We don't have a schematic for this card, and we don't have a trace view for this card. So at this point, we're working a little blind, but we want to target the physical damage and see if we can reconnect whatever damage has happened there. The crack is very, very small. And we'll actually put it under the microscope now for you to have a look, and you can see what we're looking at. Okay, here's our switch over to the microscope, and we're looking at the area by the lock-in tab here. And you can all see that little crack. It's not very big at all, but we now assume it has severed something quite vital. Right, so we have our grinding pin out, and we're going to grind away at this and see what we have underneath. Okay, so we've just completed closing the traces up. There wasn't any actual problems down there, so we've ground the crack out to the bottom of the crack. It didn't sever anything. So we still have all our voltages. We're going to plug the card again now and see if we have a boot. It's highly unlikely, since those traces looked like they were all good. Okay, so we're going to boot the card again now and see if we have any changes. It's very highly unlikely, considering that we had no problems down where the traces were. And we have no boot. For anyone that's wondering, the beep you're hearing is actually a boot from the motherboard, but it's not booting from the graphic card, it's booting from the internal GPU. So it doesn't actually know that this card's even plugged in. There is one more thing we can now check. Since our traces are fine and we have all our voltages and our PEX reset is good, we're going to start examining the area by the crystal to see if we have any voltages. Generally, if you have a voltage in and out of the crystal, you have the frequency going in and out as well. Right, so we've been poking around on this card, off camera that is. We have found the problem, and we'll put you under the microscope in a sec and you can have a look and we'll confirm this together. Right, so what we have here now is the crystal for the core. We didn't actually check this because it's extremely rare to have a failure here. In the entire time we've been working on graphic cards, we've only ever seen one other card with a failure in this area. So we don't even bother checking it. It's normally a waste of time. But in this case here, we have a problem, and we'll confirm this for you right now. So what we have here is our voltage for the crystal going in and out. Sorry, let's put the light on. Okay, so this is our voltage in or out. We're not entirely sure at the moment which one this is. We know that the crystal should be running with a voltage, normally just under 1 volt. And if the voltage is there, the frequency is there. So what we can do now is we just poke this resistor here. So I'm just poking that very gently, and we'll power on the device now. And as you can see, we have no voltage. However, if I now put a bit of pressure on the core, we have voltage. Okay, so this is a very clear indication that we have some sort of a solder problem under there, maybe a ripped or damaged trace. So we would like to lift the core now. Right, so we've just finished removing this core. Sadly, it's not good news. What you can see here, you can already see it. There isn't just the 2 pads missing from this clock that we were looking at. We knew that 2 of the pins were bad, but once we lifted the core, we can now see that the whole corner has been ripped. Sadly, these are all data lines and they're all important, and there's too many to continue with this repair, so we're going to be stopping here. A little unfortunate, but we can't foresee that without lifting the core, and this is why we choose to reball. And you can have a nice clear look of how many pads are actually missing and ripped. Even if we did try and attempt to repair on this, we're most likely looking at the same damage under this module and possibly this one. A little disappointing about the no fix. There's nothing more we can do for this device. We're going to now send it back to the customer. For anyone interested in booking a repair with us, you can contact us via our eBay page or via our website at bhawkgaming.co.uk. The eBay page link is on our main page. Thank you very much for watching.